Here we go. We're on 4C. This is from the homework on page 390. And they want you here to convert to general form. What form is it in right now? What form is C in right now? Yes, Aaron. Vertex form. Currently it's in vertex form. And as you're doing the other worksheets today, I'm going to be asking you to tell me what you know about the parabola along the way. So when you first get started, we'll ask you to find different things. They might ask you to find the vertex. They might ask you to find the y-intercept. What are some other things on that handout from today that I'm asking you to find? The roots of the function or the zeros, those are synonyms. What are some other things? Is something LOS? Do you know what that means? Line of symmetry. I'm going to ask you for that. So you're identifying all the pieces and the parts of the parabola along the way as you work. There's another one called the mirror point, and today's going to be our first chance to discuss that. Mirror point. Are there any more? 1, 2, 3, 4, 5. Is that it on that sheet? Let me see. 1, 2, 3, 4, 5. Yeah. We might also ask about the dilation at some point. Is there any dilation? Is there a reflection? And we'll just sort of discuss those along the way. So let's go ahead and do C. Do we know any of these things just based on this format that it's in right now? Do we know the vertex? Do we know the y-intercept, roots, line of symmetry, or mirror point? Can anyone? We know the vertex. Good. What's the vertex? What do you think? What's the vertex? 4. 4 is part of the vertex. 4 is the vertical shift. Okay? Remember, the vertex is a point that we're trying to find. Nope, not 0, 4, not 4, 0. How far right does it shift? 5. So it's a shift right 5 because of this. Remember that? Right 5. And this is the up 4. The 4 on the front tells you to go up 4. So as you're going through, you can now go over to the vertex and write 5, 4. You didn't have to do this on the homework. I'm previewing what you're going to be doing today. All right? It wasn't this extensive on the homework last night. So don't worry if you think, oh, I didn't do all this. You didn't have to. There's something else that we can tell right away. Once you know the vertex, there's something else you definitely know. The line of symmetry has to be at x equals what? 5. All you do is steal the x coordinate from the vertex. Boom. That's your line of symmetry number. If the vertex is right 5, the line of symmetry is right 5. Guaranteed. All right? So once you know the vertex, you know the line of symmetry as well. You don't have to do that opposite of b over 2a because you already know it. All right? Y-intercept, roots, and mirror points, those aren't as obvious right now. So let's go ahead and let's work on C. Let's think about how we convert now. Well, there are 3 steps here. The first step we're going to do in blue, and that will be to square that quantity. To square that quantity. The second step we'll do in green, and that'll be to distribute the -2. And the final step will be in red, and that will be to add on that 4 to any constant that comes out of all this. All right? That comes out of that process there. So we're going to square, distribute, add. All right? Let's go ahead and do that now. So let's start by squaring the quantity x minus 5. I said we'd do that in blue. So here we go. To square x minus 5, we have 4 minus 2 times x minus 5 squared. One of the most sure methods here of getting this right is to take x minus 5 squared and write it out the long way. So let's FOIL now. Leave the 4, leave the minus, leave the 2 alone. They're just going to wait. They're going to hang out there and wait until we figure out what x minus 5 squared is. Well, what do we get? Let's go around here. Ready? Mary, how do we do x times x? That's going to be x squared. All right? Let's do the outside inside at the same time. Ready? Let's sort of have them in our mind and combine them. What do we get when we do outside? Negative 5 times x. Negative 5x. Well, the inside will also be negative 5x. If you have two negative 5x's sitting there, what do they total up to? Negative 10x. So let's save some time and just go ahead and write negative 10x. And finally, we have last times last. Negative 5 times negative 5, everybody? 25. All right, so we have the foiling complete. That's step 1. Sorry for the squeezing it in there, but there we go. Plus 25 on the end. That's step 1. Exponents first. Then multiply. These follow the rules of please excuse my dear Aunt Sally. And the next one was going to be green. We're going to take negative 2 and distribute it. The 4 just waits. That 4, those things that we add and subtract on the end, they're very patient. They can sit there for a long time and just wait and see what happens. And then at the very end, they can combine with any constants that are there. So that 4 is going to wait there. Distribute negative 2x squared. What happens when negative 2 runs into negative 10? Positive 20, and then it also has the x attached to it, right? What happens when negative 2 runs into positive 25? Negative 50. That concludes the distributing step. Look at all this work for one problem. Well, it is school, and you're expected to do work. So here we go. Last one. Y equals. The final thing will be to take positive 4. I'm reminding you it's positive 4. Many people see this minus sign and they want to subtract. That negative sign doesn't belong to 4. It belongs to 2x squared. That negative 2x squared owns the negative sign. Plus 20x doesn't have anyone to combine with. But negative 50 and positive 4 can combine to make what? Negative 46. And that concludes the converting from one form to the other, from vertex form to general. One other thing we know from here is this, the y-intercept. What is it when you look at this equation? You just said it, actually. What is the y-intercept? Negative 46. 0, negative 46. Now, at this time, we're not ready to complete the whole puzzle. Maybe the roots are a little less obvious for this. We're going to have to do something called factoring to find the roots. And we need to make sure it's factorable. And for the purposes of this video, for going over this problem, we're going to save that for later. All right? We completed the task, which was to convert from vertex to general form. So we'll stop there.